Look at my snake head in my snake game. In the class game, we just had a square for the snake head, but if you see here, my head looks like a proper head with eyes and it looks quite fancy. Welcome back, my friends. We are here enhancing the Hungry Traveling Snake project from the YBite Python curriculum, available at www.ybite.in. In this video, we'll see how we can get a head which looks like the way I have shown it here. In fact, it turns out that this is actually quite involved. There are many steps that we have to follow. I'll go through them slowly. But I thought it's also a good opportunity for us to take a step back and understand how shapes work in Turtle in general, because these ideas can then be used elsewhere as well. Remember, the goal we have is to take from the present Turtle shape, which is a square, 20 pixel by 20 pixel square, to something more fancy, which looks like an animal head with eyes. Now, before we take a deep dive into how we can get that shape that we wanted, let's take a step back and understand how do we get turtle shape at all. In fact, we have seen this before. We can use one of the many default shapes available with T dot shape. For example, we are using square. We could use a circle, triangle, classic, arrow, and turtle. We have looked at this elsewhere. And once we get this shape, we can use the shape size or say shear factor and some related blocks to control how this turtle looks. But of course, if you want to do this in the snake game, do keep in mind the dimensions, because the snake game has several constraints that we are working with. To make sure they're all working well, the size of the snake should be good enough. The second option that we have, and that's what we are exploring here, is that we get a completely new shape, which is none of these. And that's what I'm doing. I'm going to create that shape. In fact, so if I want a completely different shape, it turns out again there are two options. One is that I can use a GIF file that contains the shape, but then this is a little bit restrictive because the turtle's size cannot be changed, and strangely we cannot even turn the turtle. So it's not really a suitable option for our let's say the snake head, because it needs to turn around. But this could be a good option if you want to add, say, a more beautiful fruit and can find a suitable small GIF. The next method is to define and register a shape. Works well for shapes that can be described geometrically, but this gets quite involved. Now, this is the method that we are going to follow, but we will look at both of these because, like I said, these ideas may be applicable elsewhere as well. So let's just see how do we do it with a GIF file. Well, the idea is very simple. Upload the file. We need to register the shape with the screen, and then we can use this. Now, to understand all of this better, I have created a separate project away from my snake so that we can just focus on the turtle shape, build this whole thing here, and then we can integrate in the main snake project. Now here I'm running a turtle. I've created a turtle with square, shape. That's why it's appearing like black square. And of course, shape size 1, 1, and hence it is the regular shape. But notice that I have in fact uploaded a cute animal GIF file. I can in fact register this shape, and that's what I'm going to do now. Now registering a shape is basically telling the screen that look, this shape is available. I can use it for my turtles. This happens with the screen, so we have screen is turtle.screen. So I just say, well, screen dot, let's say, register shape, and I just tell the name of this file. So say animal, cute dot say GIF. Now, once I register the shape, it's like telling the screen that, look, this shape is available to me. I can, in fact, say t.shape is, let's say, this animal. Now, when I run this program, notice this is my turtle. And to make sure it is indeed a turtle, let's say I say t.go to, say, 100, 100. Indeed, you notice that this turtle is moved. It looks rather big, but it's quite cute. Of course, if I had a small little image, that could have been my fruit, for example. But the problem is that if I want to try and, let's say, resize this turtle to, let's say, become something smaller. So I say t shape size to perhaps, let's say, 0.5, 0.5. This won't work. In fact, nothing will happen to the shape. Also, if I want to, let's say, turn the turtle, so I say set heading, for example, 90, I expect my turtle head to turn. In fact, this won't turn. So GIF images are good if you want to just place them somewhere like we are doing for our fruit, but definitely not for our turtle head, snake head, because that needs to turn around. So GIF, won't work for us. We've got to look at the second option, which is to define our own shape. Now, it turns out that this is, in fact, a three-step process. We first define a shape, we first register, we then register, and then we see how it goes. We can define a shape, for example, let's say a polygon or any kind of closed figure. That will be step number 1. Step number 2, again, just like we did just now, we will be registering the shape with the screen. and finally we apply the shape. So this part is actually something we've already seen. We'll see how we go about defining, let's say, a shape here. Now, as a first step, let's say, I want to define a polygon. I want to tell my turtle to take, let's say, this shape. So all I have to do is to say, okay, look, how do I create this polygon? I just create that shape and give these vertices to register my shape. I come into my code and define the polygon that I want. It's basically, well, poly is a tuple of tuples. So I just say, well, it is -5, -10. So I just give the XY coordinates of the, the polygon that I want. So 5 -10, comma, let's say 10, 5, and finally let's say -10 and 5. Now this is just a definition of the polygon, and I tell my screen to register this shape. So I say screen dot say register shape, say let's call it my shape, and comma poly. So it's like telling the screen that, look, if somebody wants a shape of my shape, please give it this poly. Now when I run this code, I get, you know so notice when I probe this turtle, it's a turtle object as always. If I do t dot shape, it tells me, well, t dot shape is my shape. If I were to try and set its heading, that is possible. So I say, for example, set heading, let's say maybe 90. You will notice the turtle turns just like we expect the snake head to turn. Something interesting to notice here is that I defined the turtle to be kind of vertical, but when the zero heading came, in fact, it was turned right by 90 degrees. So there's a 90-degree turn, but that's okay. Once we know this, that's perfectly fine. We saw that this turtle can be turned. This turtle can also be shaped and sized differently. But now from here, we need to go over and create a compound shape, which is to say that, okay, look, on top of this thing, I need to add, let's say, a curving head plus these two eyes, because that will become my shape. Now I've intentionally colored them differently because I want to highlight that there are multiple shapes involved here. There is this polygon, there are these two circles, and then there is this, kind of like an arc, but it must all fit in here. This is what is called a compound shape. Now, again, the process remains exactly the same, which means that we will define the shape still, just that becomes a bit more involved. We will register the shape, and finally we will apply the shape. Now, to do this, several steps involved here. Like I said, there's a compound shape. We have a curving section. Somehow we need to figure out a way to represent that curving section as a polygon. And we can use for that purpose these methods called t.begin_poly, t.endPoly, t.getPoly, and so on. With these, we will convert the curved sections into polygons that then the turtle can use. Let's look at this, right? Let's think about how would we go about drawing this figure. Well, if I were to do a drawing, it's a pretty interesting project in itself. I could draw, let's say, for example, a polygon. I could draw a partial circle, and then I could go and draw the two eyes, which are the two circles. Now, the mathematics behind this is a little bit involved. I'll be happy to discuss. Basically, I just figure out, okay, what should be the heading of my turtle here so that it makes a curve and goes and reaches exactly here. So the radius and the heading is what we need to figure out. Using Pythagoras theorem and basic trigonometry, one gets the answer. And this is what it is. Now, I'm going to keep it a little bit general. I'm going to say, okay, instead of fixing, let's say, to some specific A and B, I'm saying let's use variables A and B. A equals to 5, B equals to 10. So I'll get exactly the shape that I'd been looking at. Now, before doing anything else, I'm just going to draw this compound shape, and this is a 4-step process. First, I will draw the body. In fact, I've already done this, but I will just generalize it a little bit. Next, I will draw the partial circle using the formula with this, and then I'll draw my two eyes here. Let's do that first. Now, the first thing that I'm going to do is to draw the shape that I want. Like I said, the first part is the body of the turtle. So I'm just going to keep it a bit general. Say it's b is 510. I just first hide the turtle so that it doesn't come in my way. I say t dot pen up. Now this is really just basic turtle actually. I say, well, t dot go to. Of course, I have to do quite carefully because the values I could get wrong otherwise quite easily. Minus b minus a, and say minus b. I'm going to just copy this control C, say a bunch of times. So, well, and let's see what these values must be, right? So of course I say t dot pen down here, and then I have b minus a and minus b. So b minus a and minus b. um, I have b and b minus a, b and let's say b minus a. I have minus b and b minus a. Now again, uh, go through this slowly. Minus b and b minus a. You can put some specific values. It becomes a little bit more easier. And I finally minus b minus a and say minus b. Now let's just make sure that this indeed draws a body for me. If I run this code, notice I get exactly the kind of body that I would want. Now I have to go further than this. Having drawn, let's say I'll just draw this, say the body. Next, I will draw the partial circle. Let's say the partial circle. And the way we would do this is, well, again, I'll say t dot pen up. I'll draw the partial circle by just figuring out where do I need to go. Well, it turns out I need to go to t dot go to, for example, b b minus a, and I say, well, define a new variable which is essentially a square plus b square. So a to the power of 2 plus b to the power of 2, and divided by, say, 2 times a. And finally, I have this angle here, theta, that is given by math dot arc sine. Now, for those of you who know trigonometry, basically this is inverse sine of, let's say, p by r. I convert this into degrees by saying, well, 180 by, say, math dot py. Now, uh, in order to be able to use this, I will have to import, say, math. Otherwise, there will be a problem here. So import, say, math. Now this will make sure that I draw a trigonometric sort of partial circle. I set my heading to, let's say, t dot set heading to, let's say, 180 minus theta. Now again, I'm very happy to discuss with you, how these numbers are coming up, but basically from basic geometry, right? So when I say t dot circle, remember this will draw me a partial circle of radius r and with a span of angle 2 times theta. Notice when I run this code, I get like a bucket shape because this is my partial circle. Now this code is quite flexible. In fact, if I change the values of a and b, I will get a slightly different shape, but this is just fine for now. I will go ahead and draw my two eyes. So I just tell this guy, well, t dot go to, for example, b by 2 and let's say b by 2. Once again, I've worked out all this in the past, so that's why I'm able to do this. So I say t dot set heading, for example, say 0, and let's say t dot circle, say 1, and finally that's one eye. So I'll just write here, say I, say eyes, that's one eye, and I can draw the second eye as well. So now that will be basically at minus b by 2 and b by 2. And of course, I think I have to put the pen down. So I'll put the pen up here, t dot pen up over here, and I will put the pen, let's say, down over here. So pen, say, down over here. Again, I will put the pen up and pen down so that there are no extra lines created. So pen up, and after reaching the point, I will do t dot pen down. Now we have seen this before. When I run this code, notice I get my turtle head forming up. I get those two eyes as well. Quite intricate, quite interesting in many ways. But now my next challenge is, how do I convert these shapes into polygons? Because remember, previously I had registered a polygon with a screen shape. I need to somehow register a shape which is now made of multiple polygons. It turns out that there is a way to record these polygons, and basically it's very simple. I'm going to say, look, I start drawing the polygon, let's say somewhere here. So I tell the turtle, hey turtle, please start recording this. So I say t dot, say, begin poly. So it's like telling turtle, look, turtle, I'm creating a polygon. Please record for me this polygon. Once the polygon gets over, I said, okay, I'm done with this. I just say, well, t dot end, say, for example, end poly. That's a recording over, and I tell, well, turtle, please call this polygon, let's say, as the body. I just say t dot get, for example, poly. Now, likewise, I can do the recording for my other polygons as well. So I say, look, the partial circle starts here. I say, well, t dot say begin poly. So it's like telling turtle, please start recording. I'm doing something interesting. Once I'm done with this, once I'm drawn the circle, I tell the turtle, well, t dot, let's say, end poly. So t dot end poly will end the polynomial, and I'll call it, let's say, partial circle. Just call it PC is, let's say, t dot get say poly. So it's like telling that, look, get these vertices for me because I want to use them again. Finally comes to eyes. So again I say, well, t dot say begin poly. Now this is quite interesting. So I say t dot begin poly. I do until the end, and I say t dot say end poly. So that's okay, that's EDN. So END poly. And I say, well, I1 is, basically, let's say t dot say get underscore poly. So gets the polygon. And likewise, I can do for the final I, which is, say, as I say, t dot begin say poly. Now notice I'm just creating many, many polygons, telling that telling them to be recorded, and I just say t dot end poly. And finally, I say, for example, I2 is, let's say, t dot get say poly. Now, before moving further, let's get a feel for what's happened here. When I run this program, notice my shape has been drawn, but more interestingly, right now I have got these polygons defined. So I say, for example, I probe, for example, body, notice for me is a polygon. It's again a tuple of tuples, which is telling me all the vertices of the body. And indeed, if you trace through carefully, you'll realize that this is what we have formed. I can look at the PC again is well complicated, but nonetheless, tracing this, I can trace the sort of the partial circle. I can do, say, I1 is whatever I mean it is, and finally I2. Now I could have actually used any of these shapes now to register with the let's say screen to be used as a turtle shape. But here I want to make a compound shape, so I need to do a little bit more. I'm going to say, well, from turtle, I just come in here, import turtle. I say, well, from turtle, say, for example, turtle, I say import shape. So notice this shape is with a big S, and I just tell, look, I need a compound shape here which is made of many, many polygons. So I go and define, well, let me say SS is equal to shape. Now this shape is with the capital letters. I just define it as a compound shape. This shape is defined as a compound shape. I am going to add components to this. Now this is very interesting. I can say, well, SS dot, let's say, add component, and I can add all of this as components. For example, I can say, tell, well, body, let it be, let's say, red fill, and also, let's say, red borders, right? Likewise, I'm going to add my other components. So I say I've added the body. I'm going to add, for example, the partial circle, let it be red and red again. I'm going to add I1, which is now, let's say, green, and green. And finally, I'm going to add, for example, I2, which is also, let's say, green and green. Now these are very tiny, but they look nice with certain color. So I say again, say green and green. With this done, in fact, now my shape has been defined, shape SS has been defined. I need to go to my next step. So I just say screen dot, let's say, register, register shape. Well, the shape that I register is, let's say, I call it snake, and this shape is, say, SS. And I tell my turtle, well, t dot shape is, let's say, snake. Now I will do this, and I will just say, well, t dot clear, so that the drawings become clear, and I just show my turtle, and let's see what happens here. Notice when I run this code, I get the shape coming out as I had done previously. Um, Now I can probe this and see what turtle have I got. So when I look at T, for example, it's a turtle object. Now when I probe T dot shape, for example, it is a snake. That's a shape that I have defined. And of course, I can set its heading to whatever I want. So I say, for example, T dot set heading, for example, to 90. it moves 90. If I, let's say, make the turtle larger, it becomes, say, 2 and 3. So I've expanded one dimension. In other words, I can also. So that's a lot of steps, but that's exactly what I've done in my game over here to get the shape that I want, and it is how it goes, right? Again, like I said, very, very involved, but in the end, quite satisfying, and lot of mathematics to understand how the shape actually gets drawn. So this is interesting from that point of view. Now, before I wrap this up, interesting to compare and contrast the effort we did in Scratch to do something like this versus now. In Scratch, it was very, very easy because we had this point reshape tool, we had these tools available to us, a nice GUI given to us to just reshape the shape in whichever way we want. But here we had to do a lot of work to get something similar, a lot of mathematics as well. But that's the nature of the two platforms. Scratch is very visual. They have taken care of a lot of things of this sort. Here we are having to do it on our own, but nonetheless a good experience to go through this exercise and understand some of these lesser used blocks in Turtle. I hope you found this interesting. In general, if you think this way of learning works for you, where we build activities, where we enhance those activities, we think about the different ways of doing things, look at our website because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.